Thanks everyone for joining today. So again, as Greg said, my name is Zach Sample, Product Manager, XP Solutions, and we're going to talk about the world of stormwater design and XP drainage. So first, just in case there's someone new here that doesn't know, I guess, XP Solutions as a whole. So XP Solutions is a company providing original, high-performing software solutions. And in particular, a focus of mine over the years has been on that customer service, customer satisfaction. So we really pride ourselves on technical experts and technical kind of education and content delivery out to the world. So today's agenda, we're going to look at XP Drainage, and really this XP Drainage 2016. We are releasing some new updates that are pretty exciting. So we'll have just a basic overview of kind of what the product is and what this 2016 release includes. So latest enhancements, and ultimately just jump right into a live demo. And as Greg said, any questions we have along the way, I'll try to spot them as they come up and answer them. Certainly we'll go back and kind of go through any questions that I didn't see or any that are submitted at the end and go over those as a group. So XP Drainage, up till now, and certainly XP Drainage 2016, I would sum this up as XP Drainage is going to allow for quick to assemble, clear to communicate, and thoroughly reviewable sustainable stormwater plans. Now, at first glance, that might seem like a bit of a kind of vague description, but really that does focus on some problems that we have in the industry and kind of in the stormwater practice as far as design goes. So as far as the actual way in which we complete these designs, we're going to have three segments, so to speak. So first would be simply building up a model, laying out schematic drainage plans, importing existing system, placing proposed stormwater controls or items. Then we get into the middle chunk. Sometimes this is more than a third of the effort, but this is kind of the optimizing portion. So as engineers, we really pride ourselves on figuring out exactly how big something needs to be to fulfill its requirements. So the idea of optimizing exactly meeting the needs given the different criteria is a pretty important chunk. The last piece being reporting, communicating the design to others, vetting and confirming the results. So that's what we're going to be covering with the software today. Now, with the 2016 release that we have available now, we're going to look at two specific items. The ability to automate, what I'm going to call that complete unified stormwater sizing process. So most of you probably are familiar with this term, but the unified stormwater sizing process is a really great way to describe the entire design system that we implement. So it's not only sizing our facilities and our treatment systems for just a water quality event or volume, but it's also looking at the larger, what we might call protection events. So that might be something we've done for a number of years. The water quality sizing perhaps is newer as an industry. So it's looking at the full range of items we need to account for and then safely attenuate on our site. So we're looking at that kind of entire umbrella of work and really automating various aspects of that. And one in particular that we're going to, I would say, about as completely automated as you can get, we have this one-click runoff reduction practices. So we'll look at that a couple different ways, but especially with this 2016 release, our ability to kind of automate and simplify the sizing based on runoff reduction, and we'll find a couple other methods can be used to really assist us in getting this work done. So to look at this from a little different angle, you can see what we've had as far as the software up until this release has really focused on that visualized drainage design and really how important that is. So the first piece being something that you'll see right away with the software is how any calculation we're making is going to be linked into what's being shown visually. So there's no going away in the dark corner of the office and working in Excel and then handing back some mysterious design to, let's say, the site design team as kind of the answer for, let's say, our detention basin. What we're going to look at is any calculation you make, any input that you define is going to be represented in the plan view. So you change the size of a facility, you change the slopes, the batter of some swale. Well, it's going to show kind of how big that facility footprint is going to be. It'll show where the layout of the pipes or channels will be. So very, very important to have that connection to avoid a whole range of issues. Simply put, goof-ups that could happen. Goof-ups is a silly term for what can be a very, very expensive problem. Something else that really enhances this visualized system is XP tables. That's actually new to 2016, but this is tabular view of really any input in our system. So our ability to understand and clearly self-vet and self-review our models is really, really enhanced by having this robust tabular display. These automated design calculators I've mentioned in the past and we'll look at again today are going to help us, again, understand and kind of see how our controls will work. And then there's a few items like simply profiles of treatment trains, something that is a very common practice and a common tool to use to maybe vet and review a system, and maybe more advanced flood and advanced 1D hydraulic analysis tools, not often something used just in basic design or in certainly the world of kind of water quality sizing. So from there, especially with this release, we're looking at adding in that one click, as I'd call it, optimizing for runoff reduction practices. So we'll see if we can use that on individual facilities, or what I'm saying here, a little larger site, which might take me, again, I was an engineer in practice before joining XP, and so a project that I would say would take me a week to try to calibrate and size correctly, that's really kind of a push of a button now. So this certainly doesn't mean that I have now optimized my way out of a job. This just means that I'm able to more clearly get to kind of the end goal for the starting point for this design. So I mentioned before that unified stormwater sizing process. The runoff reduction sizing is just the start, just one piece of how we need to kind of account for flow on our sites. So optimizing that just makes our life easier and again, kind of prevent those goof ups that can happen. So we still need to go through and really have a human brain look at how we can, in a sophisticated way, in an elegant way, account for those higher flooding events. That begins to get pretty complex. So runoff reduction, sizing, pretty straightforward, pretty easy. Let's make that even quicker to implement so we can get on to the really complex items. That's what we're going to do with that automated sizing. So all this done in a single package, as we'll see, is really important to not have to chase through multiple different spreadsheets, multiple different basic tools. That's really what we're offering here. So to rattle off some of the specific enhancements that we put in this 2016 release, the first one is being that really robust sizing automation. This is going to be for local facilities and global optimization. Next would be the XP tables, as I mentioned, just simply tabular input and review of the model. We changed the way in which we have this build train tool. That's maybe something you've seen in the past. We can really enhance that and make it even more robust. This is a way to very, very quickly string together an entire series, a treatment train of either your stormwater conveyance, you can link up pipes and manholes, or a series of actual treatment facility systems. Something new, again, I've shown this in a couple of the detailed webinar series that has occurred over the last couple months. So I've shown some of these items kind of as they've been developed kind of in the background. This is our kind of our bow on top of the package fully completed release. So we have this 3D views item that maybe you've seen before kind of at a glance, but we'll look at that a little more today. So the last two, outfall control design assistance and just further enhancement of result summaries. Again, we'll look at these. These are numerous items, so we'll kind of chase around where those are across the software. So I guess to get everyone on the same page, I'm curious to see what, I have a poll. It's really what are kind of the primary stormwater design concerns or the focus that you attending right now might have. So I'd like to see people's thoughts on that. So go ahead and read through the options and click on ones you might have as your primary focus. So there's just simply achieving the runoff reduction, sizing, optimizing for detention basin only. So you can click more than one. So you might have a couple of these pretty routinely. Maybe there's just one. Maybe you're only looking at sizing pipes and that's it. What I'll say is we'll look at really all of these pieces in the software. So if you do have one or two that are very, very strong, certainly that's there. The point is that the entire spectrum of this work can all be done in XPDRAINAGE. So a few more people are still filling this out, and I'll share this once it's done. Great, so let me share that so everybody can see what the answers were. So it looks like the majority of people, and as expected, the just simply sizing and laying out your stormwater pipes and conveyance system, well, that's really kind of the bread and butter of the development design world for stormwater. And looks like a pretty high number of people really do have to focus on achieving the runoff reduction sizing. So that's pretty interesting to see that that is majority of people would find that being a design requirement they have to follow. And ultimately, the detention basins and outlet controls, yeah, another historically very, very common thing to look at. So that's great. So let's jump right into looking at the software itself. All right, so here's a model I happen to have. I'm just going to play through building up a system as if we're starting from scratch. It's kind of a nice way to do it. So we're looking at the software. If anyone has ever used a Windows computer or some sort of CAD or GIS software, pretty sure this is going to be an intuitive interface to work on. So we have ribbons at the top. You'll see if we work from left to right. You'll see here's just kind of general plan view, input your rainfall, pollution, design tools. Working left to right, you'll ultimately get to the analysis and the results of your system. So if you work all the way to the right side of that ribbon, well, you'll finish your project. Okay, and we have a tree view on the left, which is how we're going to be able to interact with a lot of this information. So for instance, I've already loaded in a background image and a CAD file. You'll see you can just right click on these items and interact. So I've already loaded in some data, loaded in a surface. So that's really great. I have this CAD file. So I have this site we're going to develop. This is all to scale. And I happen to have a surface, an existing surface. And that's going to tell me a lot of really great information. Place I'd like to start with is simply this we call Deluge. So this is a very simple, quick 2D assessment of my site. So we can zoom in here and see the flows across my site. Again, some of you might be familiar with what a 2D analysis is and kind of how that's used in the flooding world. And those models might take an hour or a day to run. This is a kind of a snapshot in time, and you can see very, pretty much instantaneous snapshot of kind of how overland runoff will move across your site. That's what these vector arrows are showing us. So we can see on this site, judging by those kind of flow vectors, showing us direction, and also these kind of ponding areas. I'll turn this off. And we'll see that, sure enough, we're going to have a lot of settling kind of towards the middle of our site, and ultimately water is naturally going to work its way north. So as we fill in this site, something we might want to do is perhaps have treatment kind of at this central area, and then perhaps let it work a bit more north and have our maybe high volume system kind of at the north edge of our site. So we have maybe a rain garden here in the middle, which is going to collect most or all of that runoff, and then perhaps some sort of green yet still high volume detention facility, perhaps a dry swale. Okay, so maybe a swale that has some infiltration capacity, so we can still get some runoff reduction volume achievement there. So great, so I could delineate my catchments based on that deluge, those flow arrows. That's really helpful as opposed to just simply drawing that based on contours. So let's begin. I happen to have several templates, something I've spoken about previously if you've seen a webinar before, but templates are really useful. I can define any number, so these are inflow types, junctions or manholes, and a range of different stormwater controls, let's say. So this is how I can kind of customize the tool for my project or my area. So if I simply input a design criteria once, well, that can be used again and again and again. So for instance, I'll start with, I happen to have this urban residential land use. So I will just simply add this existing catchment outline. We'll see here's my site. I won't dive into too much kind of on the runoff side. We can look at pollution concentrations. We could certainly add those. You'll see this is, I'm using SCS, rainfall record, so on and so forth. The percent imperviousness and the pervious area curve number are two items we'll look at there representing that existing site. Great, well, I just want to look at the existing runoff from my site. There's no conveyance in this area, so let's move to a different phase. You'll see how different phases I could jump to the developed site. So that's really just kind of a duplicate of the existing with the new improvements shown. I turn those on in the CAD file. So sure enough, I want to delineate this site. Now one thing we added is pretty unique. So I already have this area drawn. I did the work once, right? I don't want to repeat myself, so I could right click and duplicate that to a different phase. So maybe I could push that outline to my developed phase. That's pretty interesting stuff. So here's that same layout, and you'll see it's it has the exact same information that was in the existing. I could perhaps change that template. So you'll see here I could select the urban developed template. Well, I'll even just change the name just to see what that looks like. And we'll see here that different template, well, that has a different land use and percentage imperviousness. So that's how that could work. Ultimately, I might want to just completely draw from scratch a new area, let's say. So I could do this one of two ways. Maybe I will draw the treatment train assuming one large catchment, though maybe I want to break up this site. So we can use this build train tool, something I mentioned before in this release. We changed a bit. Okay, we enhanced this to be a little more flexible. So perhaps something I could do would be, I could just simply add a train. That's what this button here does. So it's going to start by connecting to this inflow area, and I might say I want to use this green street system. So see, the next item to be drawn will be a green street. It's really just a bioretention system. So I could plop that here, and we'll see that, oh, you know what, maybe that's too wide, so it gives me kind of a width that I can draw. See, so I can kind of change on the fly how I lay out this system. Now I want to drain this site towards the middle of my catchment. Maybe the next thing I want to add would be some sort of drainage pipe. So we'll see if I hold control, I can add in vertices along that pipe. We'll see what this looks like in a second once we finish. And I'll say, hey, typical swale is kind of the next item I want to add. And maybe this is 40 feet wide. So there we go. So we've just added in this inflow area, all drains to this one central basin, and there's a pipe that drains out to maybe our high volume, high flood event system. All right, so we laid this out. Let's just take a look at what our profile would look like. So something interesting right away, we'll find that having a profile, I laid this out kind of knowing this would be what would be shown. This is something that's so easy to miss when you're moving between different tools, different spreadsheets. So we can, of course, see this through tables. We could see this even easier through this profile. So perhaps we need to adjust the height of this pipe. We'll see the downstream invert. Perhaps it needs to be closer to, let's say 140 or 1845. And I'll show you, kind of move that off screen, so when I update it, we'll see it automatically updates in the plan view. Perhaps that's not enough. Maybe we need to daylight, right kind of out onto the surface of that swale. It's a pretty easy way to just visually adjust that pipe and how it's all connected, right? So the input data is shown here. This is the profile. Vertically is going to show us what's going on. Again, this is all linked into our plan view of the system. And so what do I mean when I say it's linked? I could go and look at this bioretention system, let's say, and we could size this facility. So right away, I want to size this for the runoff reduction event. First thing I could do is, I'm not really happy with a kind of rectangle. I want to see a little different, maybe a more organic shape. Let's take a look at what this, show this item. So you see you can change that outline. And now I could, let's just say, adjust. Here's the kind of the physical description of my bioretention system on the left. I'll show an image. See, this is what we're talking about. Here's filter layers. Here's a ponding storage area. So this is saying ponding area. Here's the top. Here's the bottom. It's 1.2 feet deep. I could change that. Let's just say this is 2 feet deep, just for example. Okay, based on your local requirements, that's what you can save as a template. So you don't need to change this. You set it in once, as let's say there's 7 different types of rain gardens or bioretention systems that your area, your city might advocate using. Well, those become your 7 templates, and you're ready to go. So one thing I could do would be perhaps to, so this radio button here, this is what's going to be automatically calculated for us. So it's pretty useful to kind of give the software 2 values and have it calculate the third. So if this is my base area, and you know what, I actually need to mow this site, so maybe this is going to be 1 to 4 slope. Well, see, my top area, my top footprint is going to change. So if I hit apply, you can see how that has adjusted the size of my facility, always being locked into plan view. Something I mentioned in previous demonstrations. All of the plan view, that information we can save to a CAD file at any moment and share that with the rest of the team. That's part of that communicating and clearly understanding our design. So we don't, again, go in the dark corner of the office for a week and no one knows what we're working on. Every day, we could save what our plan is to CAD and have that be referenced kind of by the rest of the team so they can see what we're intending. So nobody puts the egress from the site through where the pond needs to go, let's say. So I'll put that back to 0. Let's just size this facility. So here's this sizing calculator tool, and we have a number of different options here. The default would be the runoff reduction volume sizing. So pretty interesting. We could size this to that. We could also just scale the facility up. So you can imagine that's just entering a number, saying I want this to be 50% larger. There's also a quick storage estimate. So if you give the software the input, the flow it will receive, and then the restricted outflow that you want to achieve, right? So think of like a detention pond. I know what's coming in, and you know what? I can only discharge this amount. It will give me an appropriate storage volume for that. Let's just stick with runoff reduction. I've talked about that a few times now. And now I could look at what's my design criteria. So just, hey, this whole facility needs to fill up. Okay, well, that's the exceedance level. That's the top of my facility. Often we might have the freeboard. So that would be, that kind of safety margin at the top. We need to size the facility, but you know what? You can't use the freeboard, so we could use that as a design criteria. Something I think is pretty neat. What if you have in the real world some sort of high flow bypass weir, right? And I want, to size for my runoff reduction volume storage, but I can't assume the storage is above the height of the weir. That wouldn't make sense. So you could select lowest outlet, and it will stop the sizing based on some sort of outlet structure that you have. Okay. So let's just stick it for now with the default, the exceedance. And we could change the area, the actual footprint of the site. We could change the depth, so on and so forth. So you can do this individually for all the different types of controls that we have. Bioretention, swales, all of which have under drains, trench drains, underground storage facilities, you name it, it's kind of all in here already. So let's look at very simple runoff reduction, and just use the plan data. So all you have to do is enter in the precipitation depth in your area. So this probably going to vary between 0.8 and 1.2. Coastal areas perhaps more 1.2. Let's just say 0.8 just for grins, just to start. And we'll see probably this is a report. Of course, we could print and we could show. So I could unhide. I could show every column. You can see how the breakdown occurs. I have a volume in my ponding area. Here are my filters. Here's the breakdown of void ratio. Okay, you can hide some of that just for clarity's sake. So for this first round, I might look at, oh wow, this area is really big. So I think it's 6 acres about there. This is producing 15,000 cubic feet of storage. My facility is nowhere near as big as it needs to be. So untreated volume and it's failing. Well, I could just start with saying, okay, bump this facility up. The opposite's true. Hey, what if my facility that I just simply drew on my site was way too big? It will shrink it down as needed. So it's going to go both directions. So, I'll click OK and adjust the sizes, and we'll see, right, here's the total area that I need to treat for the runoff reduction volume. Well, that might not be kind of what I want to do. Clearly, I can't really fit that in between the buildings. Maybe I could either break the site up, okay, and have a little different drainage, as I mentioned before, or we could get into kind of more of a series of systems, a true treatment train. So let's say, again, I'm working very naturally, right, through what I would do on an actual project. Maybe this first pass, this doesn't seem to work. Maybe I need to change this design. It's as easy as I can just duplicate this phase, and maybe I'll rename this to split site. So now, okay, maybe I want to replace the outline and split this into 2 pieces. So the central area will all drain to this one facility, and the rest of the site will all naturally flow down to this dry swale we could have. So here's just another, I'll add another one of these catchments. We'll see we are going to have 2 catchments in a second. What I'm not showing is all of this information, either stormwater controls or these inflow areas. These can all be imported, from a CAD file, from GIS. I'm just showing the most direct manual way to do it. I could say, let's just connect this inflow to this facility. So this area will drain to this swale, and this area will drain to this bioretention system. So maybe I'll start now looking at sizing this facility one more time. So now with this different inflow area, we'll see much smaller required volume that we need to hold on to. So I can size to that, and it will shrink down my site accordingly. So see, now we have a much smaller footprint that we need to kind of contain this flow. And again, I could replace the outline to be a little more organic, a shape, kind of a meandering kidney shape, if you will. All right, so that's maybe the layout I want. So this is kind of that landscape architecture, that planning point of view. You're really laying out how you want the facility to sit. And I could just force that sizing one more time to make sure that I'm meeting that requirement. So this is absolutely addressing the runoff reduction volume for this part of the site. We could do the same exercise for the swale. So what I didn't show here is we could get into some more advanced items. We could start looking at infiltration into the kind of in situ or natural soil. We could look at pollution removal rates. I'm not going to get into that level of detail, but certainly that's here, and it's quite easy to do, to have the different reductions in your facilities. That's usually something that's dictated regionally. So great, from this I can just simply run the model. One thing I didn't do was I didn't change. I have these different inlets and outlets. Well, again, that's what happens when doing a very live presentation. I didn't update that. So I'll go and I have one too many inlets, and now I can solve my model by changing those. So one thing I didn't do in this system is I didn't really add an outlet for either of those controls. So we're going to see these facilities fill up like bathtubs. So I've run the model, and here's a kind of a at-a-glance report of how well the system is working. All the reports, we can just look on the right, is usually kind of the engineer in the know thing to do. So if you look at this right away, status okay, that means is it flooding or not? Next thing I want to care about is how much capacity do I have left? So for instance, I have this percentage available in my two different facilities. The swale, I didn't have any sort of outlet. And this bioretention system, I only have that small kind of under drain. Maybe that's not even something I want to use. So we could look at the different rainfall events. We'll see here, they're flooding, and we even get indicators in the plan view of the site showing kind of how that's flooding. I could look at this in profile to maybe get an even better idea, right? So with no real outlets, like I said, these are just filling up like a bathtub. So we could show, for example's sake, how to add in some sort of outfall system. And one way to do this, let's just say if I go to this results phase report, I want to see what the existing events looked like. So again, we'll look back at this in a second. But if I want to size for the 5 and 100-year events, so this would be the 5-year event comparison, the existing site and the developed phase. You'll see we have about 0.1 cubic feet per second that we need to reduce to in our 5-year, and then we need to have a little over 3 cubic feet per second in our 100-year events. So maybe that as a guide, I could add in outlet structures for this downstream system, be it a pond, be it this dry swale. I could enter in the information. In this case, I might have a multiple facility, so I'm going to have an orifice and a weir, okay, making it a little more complex for the demo. So this is part of that kind of outfall control assistance that I mentioned. So let's have a weir, let's have an orifice. And again, I could enter the information. I like to use some of these design assistants. So the orifice will be kind of sized for the 5-year event. So I know that, let's just say, this is going to be 2 feet deep. And I want that to be only 0.9 cubic feet per second. The weir, I'm going to have at 3 feet. I think it was about 3.2 cubic feet per second was the goal there. So if I hit calculate, it's going to automatically find the width and the size of the diameter that I need. There we go. So similarly at this bioretention system, maybe I don't want an under drain, and maybe I just want a weir. again, just to show an example of what this could look like. Maybe I'll say this is kind of a 4-foot weir at the end of my facility, and I could run this model one more time. And, let me just adjust. There's a retention time on there that I didn't update from a previous test. That's one of those advanced items that you don't really need to enter, but as a product manager, I tend to dig into the weeds sometimes. So we'll run this system, and we'll find that this is going to be a lot more appropriate. So if I was to perhaps now go through the long section, let's say. So if I go to the treatment train, we'll see much smaller. We'll see how the flow actually fills up the filter media and the ponding zone. We get a really good idea of how this system is working. You see the 5-year event. It's all quite reasonable. 100-year event. Really look at that downstream facility, how I'm sized just below the freeboard, which is what I wanted. So pretty quick to size these facilities where you need them. Clearly for that runoff reduction event, very, very quick and easy. Making it fit on the site in this case was kind of the fun part. And still, maybe I'm still having some flooding concerns at my bioretention system. So in this case, I'm actually still using the kind of lumped site. Well, maybe I need to split up that site. If I could show the results for that, we'd see it be a little different. So I could switch to that, show those. I actually have another model I want to jump to just to show the automated sizing. First, perhaps I'll glance at what the XP tables would be in this. Is a little different kind of run. I did this work already once. You can see this kidney-shaped split catchment. I just want to show what the XP tables would look like with 2 catchments, so keep it pretty simple. So XP tables, think of that simply as Excel. So we can look at the input into the system, change this around, input area, so on and so forth. We can get into the inflows, junctions, let's say manholes, stormwater controls. We can add in all the different input information. In this model, I really only cared about the connection, that pipe that I have, and the inflows. So I could look at, here is pipe information, couple that with the results. I could go to the results connections, and we'll see that the flow capacity, so that's the flow versus the total capacity of that pipe, we're really right where we need to be. So you might say, let's say under 80% capacity is quite healthy. So just a 12-inch pipe on this small site is doing a great job. So we could try to optimize that further. There's some automated tools for that. One simply being the in the connections input form. There's only one pipe in this model, but I could look at that treatment train and we'll see that I could calculate, hit this calculate button, and it can show me what a rational method design would be for that pipe. I'm not going to mess with that now because I want to move on, but that's a way, kind of one click, again, you could size a system size a pipe. So that's great. We looked at some of the results. This is a pretty small site. So how does this stack up? It's really saving us a lot of time. This is a pretty smooth and robust way to build a site very quickly. But something I've shown in previous examples is a much more complex site. There's over a dozen different controls, different kind of network paths. So how would some of these items work on a larger scale? So here's what XP tables looks like with a lot more information in the system. You'll see here I have stormwater controls I'm looking at and the breakdown, the top, the bottom of my facilities. Maybe there's freeboard you want to change. I could go ahead and change some of the input into this model. For instance, maybe I can jump to the inflows tab and you'll see maybe the curve number needs to change. So I could say this needs to be, maybe this one's 75. And maybe there's a several of these that need to be different. I could go up here and say these are all 82. You see it pushes those all out using this little calculator tool up top. So pretty robust. I'm not going to dig into it too much, but you can imagine how helpful that is to really see all that input data in a tabular form. Something we can do on that larger scale. So you can, for small 1 or 2 facility sites, individually sizing is great. But perhaps I want to look at the runoff reduction for everything on my site all at once. I didn't get into the fact that we have a number of different ways you could do this. There's 2 different methods you could use. Runoff reduction is what's used all over, let's say, the Southeast, up through New York, Georgia. This is really the shows the formula right here, the standard way to do it. I could just manually type in something for the whole site as kind of a starting point site-wide. But in this case, I happen to have all of my inflow areas already designated. So why don't I just say, here's the input. I could say 0.8 again and calculate. Actually, let me just go ahead and fix this again. This was something from my previous work on that advanced side. Okay, so right away, we have a lot of options in this form. It's really the exact same thing we have in the individual sizing. So I'll mention right away that we can show everything that goes into this model, and I can hit report, or I can hit print. And all of the input data that makes up these volumes, all of the inflow constituents are accounted for. So this is not only the way to size your whole site, but also this is the way that you can report, kind of all in the same tool. So with lots of these options, again, the defaults are kind of usually what you'd accept. So perhaps I'd say, my site is way overachieving. In this model, though I didn't look at it with you as a group, there happens to be a pond. This downstreammost pond, maybe I don't want that to be used in relation to this runoff reduction sizing. So maybe I'll simply uncheck that, and it won't use that volume towards my goal. And we'll see that, well, sure enough, I'm nowhere near meeting the inflow demand at this point. Even if I remove the inflow area that drains to the pond, I'm still not meeting this item. So I can design in this lower section, I can, in this case, amplify all of the sizes of these facilities in one go. So before I hit apply, maybe the swale on this site, just as an example, maybe I don't want to change the size of that swale. So I could lock that facility from sizing. You'll see in this case, I'm kind of way over attenuating for this. So you can see the volume that this facility is providing and how much the target is. How much do I need to capture for runoff reduction? So I'm doing an overly good job for this one facility. But that's okay. Maybe that's something I want. So if I lock that, I can apply sizing. We'll see that it sizes the rest of these facilities based on these individual inflow items, all in a click of a button. And sure enough, we have a little extra because of that swale. So I click OK. We'll see the size of these facilities have all been bumped up. In this case, it's a pretty extreme example, so they're all much larger, 3 or 4 times larger than the original layout. But for presentation, it's nice to have something big and bold that we can all see. You see, this one isn't that big a change. That would be a way that we would have an entire site sized just a click of a button. So one other thing I wanted to point out, something pretty interesting, would be looking at the 3D results. So for example, I can go to show results for this facility, and I could look at the time series information for this site. So I could get into maybe just a chart of the rainfall versus outflow, or just inflow versus outflow, graphs. I could look at the actual time series information. I already looked at kind of the overall summaries. This is for one facility, all the details that really you'd ever care about. Pollution. I didn't run the model with pollution, but we could get into that. 3D is what we want to look at. It's a pretty unique thing we could do. So I could say, all right, here is my facility. I could begin to show, right, you can watch the animation. I could play that through even. We can see this facility fill up. You see the actual filter area fills up, as well as that ponding zone. And this, isn't being made up. This isn't make-believe. The software is actually taking into account the volume and how it's distributed across the filter zone, as well as how it fills up in the ponding area of the model. So this is showing off kind of the robustness of this solution, even though it's pretty straightforward to put together. So I go back to a different point in time. I could look at this, different angles of that facility. Again, just another review tool, even just something to show to, maybe someone that's not technical. So here's this swale that I have with this under drain. This is what I call that dry swale idea. So pretty neat here. We can see how this facility is on a slope and how this would actually fill up. All right, so one of the most common issues you're going to have using a spreadsheet, using some of these basic tools. Well, in the real world, if your facility is on a slope, it needs to be accounted for. Some of those tools, it's very easy to overlook, or you simply can't take into account the slopes and how there's really ineffective storage at one side of the facility. It's a pretty neat way to, once again, kind of vet your design and explain this to someone else what you're proposing. We could change our different rainfall events. I could change this to be just that 5-year storm. We'll see it's not going to fill up nearly as much. And one last item I want to show, under the review results, I mentioned there's kind of the general summaries. One item would be these, the connections, the flow summary. So as far as designing the pipes, we can use that automated tool based on the rational method, probably pretty conservative. So usually you might start with a standard size in your area, be it a foot, plastic pipe, PVC pipe in this case. Maybe it's an 18-inch RCP. So you have a starting point, and we can look at a list of the flow capacity for the system. And hey, if it's over 1 or if it's over 0.8, right away you're going to have to know you're going to upsize that. That was one kind of item I mentioned before I wanted to make sure that we looked at. So let's look at this again. What's the difference between XPDRAINAGE, this tool we're looking at right now, and XPSwim or XPStorm? So some of you might be familiar or already users of XPSwim, just another product that XP Solutions provides. And it simply put, XPDRAINAGE is purpose-built to address stormwater design and the water quality systems that are really becoming paramount in most design and most design scenarios. So we're really going to focus on the ability to size our facilities as we looked at. Size a system on this under 100-acre as a general rule area. So site development, retrofits. This works for green development as well as maybe retrofits in a city. That 100 acres isn't fixed, but that's kind of a general idea. So XPSwim and XPStorm, really quite similar products. They can do really everything you could imagine. They can look at 1D, 2D coupled flood modeling. They can look at sanitary systems. They can look at some water quality elements, though it's nowhere near as straightforward and robust as XPDRAINAGE is. So where XPSwim is great for those really large analysis projects, where you're doing floodplain analysis or large citywide storm sewer, CSO issues. Drainage is meant for really the design group, design purposes, and kind of this smaller stormwater analysis. That's really the best way to describe it. So in this case, in this small example that I had, question was, is the swale only analyzing the basin this area which drains to it, or is it analyzing the flow from this other structure? So maybe this other more complex system is even better to look at. We're going to analyze the flow throughout this system. So that's really the point, is we're going to assess the true kind of complex flow across this site. So let's say this pond downstream. This pond happens to have this area draining to it, and also has 4 different inflow kind of point sources into this pond. All of that inflow, the hydraulic, the hydrographs that go through our system, discharge into the pond, that's all being accounted for. And then, of course, based on the outlet control, right, flow will leave and fill up this facility accordingly. So yes, it is taking into account all of those different systems. And one item here is how does the tailwater, how does kind of the downstream control work? So in 2016 release, we are going to take into account when there's a higher level of water surface level downstream. So we're going to prevent, it's smarter than that. It's not just going to kind of stuff flow into the next downstream item no matter what. We're going to stop flow based on a tailwater influence. Something we're planning for the next release is to have more robust tailwater control, to have time varying series and whatnot. So that's something that's will be coming up here quite soon. So one question, how do I identify the curve number? So the curve number, a couple ways you can do that. In this case, I just simply defined the pervious curve number and gave it the percent imperviousness. There's also time of concentration, which kind of goes along with the site description. There's a calculator for the time of concentration I would show. You can pick kind of the different method, kinematic wave, what have you. So usually the land use, given your site, given the percent imperviousness, you would have to kind of weight that. There's no automatic tool to do that, so you designate kind of what you have. So one great question, if you're familiar with, I guess, XPSwim or XPStorm, so I guess the way some of those programs work is the licensing. It really is kind of dictated by how big a system you have, how many nodes you have in the model. And that's not how this works. So if you, purchase the software, it's the software. You get it unlimited. And in fact, that's actually the evaluation as well. There's no restriction. It's just the software for 30 days to try it out, sink your teeth into it. So there's no restriction in that regard. Another question, will the, the overtopping and kind of maybe alternative flow paths of a pond or facility. So that's something that we really pride ourselves in being able to do. On the build system, we could look at the different types of drainage conveyance systems. We call them connections. I'll even show that here in this list. So the different connections we could look at. There's also bypass systems. And so when I talk about, it's important to assess what's really going to be in the real world. Usually, almost every case, if you have, say, a bioretention system, that's going to be sized for that water quality event. What happens when it rains, like in Texas, it rains 16 inches in an hour, or in a day. Well, that, the high flow bypass, you're not going to have a rain garden treat that. You're going to have a high flow bypass system. And so you're going to be able to represent that by a bypass channel or maybe another vault with control structure and underground pipe. So we're going to be able to assess both of those systems. And if you see your system flooding, there's indicators in the plan view, indicators in the profile, and all the report summaries will show you if you've exceeded your capacity. All that's going to identify perhaps you need to upsize your outlet, perhaps you need to implement some sort of system of bypasses. So there are some more questions on incorporating retention systems. All of these items I've looked at, I guess the way I'd answer that is, so I'll look kind of through our full list of all the different types of controls we have. Any of these can be customized. So there's just a bioretention. There's an infiltration trench, there's ponds, porous paving, I didn't mention. I'm going to call them soakaways, but underground injection wells. If you're lucky enough to permit one of those, all right, we can implement that. Tanks, swales, what have you. Any of these systems can be customized. So if I go into my model and I have a swale, so I mentioned a dry swale, maybe I have a trench. Maybe I don't for my swale system. We can see what that looks like here in this image. So here's underground trench. So minor events get infiltrated, larger events can just be conveyed. So with this one form, we can represent just a standard roadside ditch. Might look more like this. Maybe we have a dry swale. Maybe we have different types of depths and void ratios across that site. And some of those advanced items that you can really usually ignore. But again, if you want to start accounting for some of this stuff, it's here. So you could have a pond, perhaps, that has a very high infiltration rate in the in-situ soil. So you could account for all these different criteria in any one of these, let's say almost a dozen templates. So you can have a high range of customability for your site. So, do you want a size for just retention systems, high flow bypass? Do you want kind of mixed use facilities? A true treatment train down your site where each facility does a little bit of the job? Absolutely, you can customize this. So here's one item talking about looking at pollutant removal. It's something that I skipped over a bit during the demonstration. So let's look at the results for this site. So the input, I'll show the input. We can go to pollution. And actually, I thought I had this. Let me just check in my model. I had one that had, voila. So this one I actually had some local runoff, wash-off rates. So here would be my suspended solids, phosphorus, and nitrogen. Pretty common three. Maybe often it's just suspended solids. I think in the question it was looking at phosphorus. So this perhaps is the wash-off, just milligrams per liter from this site. So that's what this area would represent. And each of these facilities can get pretty advanced. So what's your removal in the either just the ponding portion or the filter pollution or the filter part? So this is pretty robust. So you might think of a lot of the criteria might be on, great, well, assuming that the water goes through the sand media, you have a certain level of removal rate. Okay, well, maybe there's no removal just in the ponding zone. Maybe it's really well vegetated. Maybe there's some, TSS especially, some settling which would occur, some removal in the ponding zone. So you can account for both filtration and ponding zones, how removal will occur. You can see you can just simply apply a percentage removal. Perhaps it's a little more academic, but you can get into first order decay removal as well. So pretty robustly, you can analyze filter and pollution zones. Ultimately, if I was to look at the results for this area, let me just analyze this model one more time. We'll see kind of what this removal looks like. So let me go to, these are really great questions. I'm really excited that everyone's asking all these items. Only so much that I cover in that sweep of my webinar. So this is great. Let's look at this facility. I can go to show results. And let's look at the charts, the breakdown of our kind of inflow into our system, pollution generation, the outflow. So we get a breakdown of what's bypassed, the total that is grabbed and removed from our system, and how this would occur in all of the different events. Usually you look at pollution just in the water quality event, but you can look at what that would look like in your more catastrophic protection events. Again, diving into the details, we can see the time series for all these different items. Okay, pollution, just volumes and flow rates. So all these facilities, and ultimately for your whole site, we could look at the pollution removal. So thank you for asking that. That was really great. There's a question just about a couple different types of specific treatment, maybe proprietary treatment facilities, underground cells. You absolutely can do that. You absolutely can represent underground tanks. I like to think of them as like the milk crate stacked up containers, or different types of semi-pervious underground facilities. So absolutely can represent that. So again, thank you everybody for joining today. This was great, and everybody have a good day.